So hi, everyone. Thank you for, of course, the opportunity to present behind the scenes of CartograPlant this afternoon. It's the afternoon for most of us, hopefully. My name is Risharde, but most people call me Rish, and I'm the lead developer at 3GenesDB, and thus, of course, I work on CartograPlant. I'm super excited to share with you some of the technical aspects of CartograPlant this afternoon. In particular, the world of map layers and the technology that creates the CartograPlant experience. But before I begin, I just want to thank the entire 3GenesDB and CartograPlant team, since this would not be possible without them. And of course, curation is part of that team as well. And of course, our fearless leader, Dr. Jill Wegazine, as well, for her leadership and direction on this exciting project. So with that being said, let's get into it. So today, we'll be touching swiftly on the following sections. Particularly, I was asked to speak about layers, the environmental layers and data. So, of course, that's what we're going to start with. What are layers? I'm going to explain a little bit about layers. You may know a little bit about it, but I've still mentioned it because it's going to build up into how we do some technical aspects in terms of rendering layers and so forth. Of course, I'm going to speak about the types of layers that I've come across working on CartograPlant, how we work with contributed layers and data, and how we go about serving these layers, because there's a lot of stuff that happens in the background, even though you just see a single map where you work on most of the information and plants that are available. And at the end of it all, you can of course ask questions, and I will try my best to answer. I don't know everything about GIS, but I know from the experience of working on the project, I kind of have a background knowledge of it. I learned in the process of building as well. Just before we get into some technical aspects of layers, we've compiled over 900 layers, as Jill would have mentioned before, into CartograPlant. It's been quite a journey. It's been a fun journey, I must say, a challenging journey, but fun as well. We try to organize them into groupings to make it easy for you to find a layer you might be interested in for your research project. That varies from forest fragmentation to species range maps, climatic variables, to density populations, and all that is in between as well, right? We have some basic statistics of what gets accessed for the year on our CartograPlant.org website. And from the graph on the right-hand side, the blue one, it shows that mean annual temperature is one of the most popular ones that is available: forest fragmentation risk, tree cover, major soils group, and mean annual precipitation. So those seems to be the most popular layers right now. But of course, you have the chance of playing around with CartograPlant and changing those statistics real time, pretty much. Of course, today we're talking about layers and data and how it works in CartograPlant. So let's get to what a layer is. I'm pretty sure most of you know what a layer is on a map. You might have used Waze, you might have used Google Maps, many of these services that use GIS layers. So you've probably seen or used one of them. But if you have not, skip all of that. Just head over to CartograPlant and play around with CartograPlant, and then you'll be able to mess around with layers and the environmental section that we have. We think of a layer just as it is, an image that is placed over a map, which is another image, because basically a map is already an image. And then when you place a layer on top of that, it's an image again, but it's a special image. If we were to Photoshop doing image editing, for example, that would be accurate. However, a GIS layer it goes a little bit further, if not a lot further. For example, a species range map, such as the one in green on the left-hand side here, this layer represents a geographic region. In this case, a large subsection of Canada in this example, and is therefore based on boundaries, as you could see there. It's a little bit small, but hopefully you could see it. While the purple or the pink layer represents individual trees on our cartography map, which are based on more minute points on the map. Both examples use georeference data, which is a big term to refer to the geocoordinate referencing system. But I think it's obvious that one is showing a range and one is showing individual points. So the range maps, they use polygons in the background, polygon shapes in the background, which is a little bit more complex to define. Obviously, there's a little bit more mathematics involved to understand it. While the points on the map, the ones in purple or pink, are single coordinates, which are much easier to define because you could define them individually. In the previous example, both of those layers were vector formatted layers. These are the terminology that you should probably be aware if you want to get into GIS and that kind of stuff. Vector data is usually made up of vertices and paths. They are calculated mathematically or have a mathematical representation. So what we tend to see in vector layers are polygon areas. Example, the range map, as I said on the left-hand side, the green one here, that is a polygon being drawn to show that range map. And even the points that you see in the pink or purple, that is not polygons, but those are actual points. And they are also part of vector layers, which is this, of course, this section here. On the other hand, some of our environmental layers, such as our world climate layers, are rasterized layers. So there's kind of like two different types of layers basically, and they're made up of a grid of pixels, just like normal non-georeferenced images, such as photos from a camera. So this section here is mathematical. This section also has some mathematics, but it's actually rendered. It's actually like if you had a photo on top of a normal map. So rasterized layers usually have georeference data, which are used to position them accurately on a base map as well. And that's where georeferencing all comes in, because everything has to fit on this map and on the Earth, and has to be at specific points. And that's what they mean by georeference data, so to speak. So why two different types of layers? This slide summarizes the advantages and disadvantages. And if you notice from the points that I'm making here, they're basically inversely proportional, right? So vector layers, being mathematical in nature, they tend to be actually smaller in size compared to rasterized layers or rastered layers. The mathematics generates them on the fly. So rastered layers and rastered layers, the ones on the right, are not very mathematical in nature. Consider them to be pre-rendered, thus they take up more data in general. So a vector layer, for example, the ones on the left, they might be, very small. They might fit literally on a floppy disk, if anyone actually uses floppy disks nowadays, but they actually are actually small enough to fit on a floppy disk. While it's not usual for rasterized layers to be like 10 gigs in size. So the right-hand side, those files are much, much larger. They're tens of thousands times bigger. And this leads to natural opposites in how they are processed by the user interface. And we use Mapbox to render all of these layers on CartograPlant. Vectors usually need to be rendered on the fly, and this can be more CPU intensive. So because it's mathematical, more of the CPU is in use, and that's literally the CPU that is on your machine. So while you are rendering the left-hand images, that is more on your laptop or your computer that is doing most of the generation there. While on the right-hand side, there's probably a little bit less CPU usage being done. So raster layers are mostly pre-rendered already. So it's rendered, and what happens is, what's interesting about this is it's actually rendered, well, with the help of middleware, it's rendered at different zoom levels. So when you zoom in on a map, you get a different sort of rendering aspect that is happening in the process, and that is actually done with our servers in the background. A perfect example of this can be seen in CartograPlant, where we use vector type layers, vector type data to display tree snap trees. The purple tree points that you see there, those are actually tree snap trees. And since we have only about 7,900 trees that's loading, the render time isn't terrible, right? So it's like 2 to 3 seconds that you see this this layer appearing on the screen. But if tree snap trees, for example, were to be 100,000, I don't know, maybe that will happen in the future, we'd have to think about converting the layer to something that is more speed efficient. When we originally had tried the vector method for importing 1 million trees using the BackEnd dataset, of course, it took over 30 seconds, and I don't think anyone really wants to wait 30 seconds for a map to appear. And this is just an example of what we do. So on the right-hand side, the example that I showed there, that's actually over 1 million trees being displayed on CartograPlant. And of course, that loads within seconds because we use a rasterized layer and we don't use the vector layers to do that. Of course, at the end of the day, it's not just the data, it's also a special engine we use. So we use Mapbox.js. For those of you who may not know about it, you could Google it. It's actually an open source map rendering user interface JS library. That's a long way to just say it runs on JavaScript, and we use that to render all of these different types of data in the process. Thankfully, we didn't have to build this. This was already built. But most of the software that we use on CartograPlant to get things going and to glue things together, it's all open source, which is awesome because you can also use it. You can also probably create your own projects with it as well too. So I'm touching on that as we go along as well. In case you ever want to contribute, of course, towards CartograPlant or come across using these formats, this use from useful papers, etc., let us know as well. The formats with the asterisks at the end are preferred, since those work well with GeoServer, which is what we use as our tile server for CartograPlant. So from the CartograPlant perspective, Mapbox.js, our open source library, renders the map to the user. So when you visit, Mapbox.js does that. But the map has to come from somewhere else. It has to have a source, basically. It's not just the file. So it's not just a file that you get and you just use that and you throw it onto the map and it appears onto the map. There's a lot more that's happening in the background. So GeoServer is an amazing open source tile server that we use on the back end to serve our layers to the UI. A future slide will show the workflow in a little more detail when we're summarizing at the end. There are many other GeoServer formats out there. And so what we end up doing is that there are other formats which we usually convert, like less popular formats that we may get from studies. We would generally convert it into a format that GeoServer is able to read. But from the list, the original 1 million trees from BN were initially formatted in GeoJSON vector format. And then it was converted into something called MB tiles, which is a rastered layer, using something called Typicano to do that. And that is something that Mapbox actually recommended for us to do in order to get those million trees to appear very, very fast on the map. And this made the million trees bearable and efficient since it compiled the MB tile layer, which the tile server, which is GeoServer, actually could handle. So remember I mentioned that the tile server does rendering based on zoom levels. So when you zoom in one time, you get a new aspect, you get a new aspect ratio, something looks closer to you. That is actually being rendered usually in real time, and GeoServer is the amazing piece of software in the background that is doing that. In other words, it's not, as I said, an absolutely simple process sometimes. The format has to be right for us to get this to work correctly. A lot of the time was spent manually converting public layers that we found on the internet into compatible layers that were suitable for GeoServer and thus suitable for Mapbox to render. So as you can see as well, CartograPlant leverages a lot of the open source technologies, plus also it uses our custom open source code to glue things together. And we actually have a GitLab where you can actually look at most of the code that we use to get CartograPlant going. So what I want to mention very quickly, just to go slightly off topic, not really off topic, but I have to mention how we convert these layers. It's not just a simple thing like you could just open it up in Notepad and edit something and then it works. So there's a special piece of software we discovered, also open source again, that we use called QGIS. And QGIS allows us to do two super important things in the process of converting layers. One is, if it's in a format that is not desirable for us, we can easily convert it most of the time from whatever that old format is into a new format. And I have a screenshot there to show you how easy it is. You basically right click on a layer, click export, and then you can actually choose the format that you want. And then there's a second thing, which is that all layers aren't always, they don't always have the same coordinate system. So think of like, there's different types of coordinate systems outside there. And basically, if you use the wrong coordinate system, when you place a layer onto the map, it may actually show up let's say a layer should be in North America. If you use the wrong coordinate system, that same layer might end up showing up in Europe. And so we actually have to standardize, the majority of the times we have to standardize those layers so that they show up correctly on the map. And this QGIS software, it actually makes it very, very easy for us to convert the CRS, which is the coordinate referencing system, in order to get that standardized as well. This is just some of the layers that it supports. This is QGIS, what it supports. And so this is kind of why we use it, because it's free. It's pretty fast. And it also allows us to create styles for GeoServer. So anytime you see those colorful maps on CartograPlant, basically there's a specific style that we had to create for that specific layer. And so it's not 900 styles. We have 900 layers, but there's a few, probably 100 styles in there. And we also use QGIS, which has this really awesome user interface that allows us to adjust those colors and so forth as well in the process as well. So I know I mentioned that GeoServer is a tile server, and I just want to touch on that very quickly. I just want to explain what that is, what it does in the background. Serving a single file would take more than a few seconds to download, because these files could be 10 gigs in size, right? And as you can imagine, that would take quite a few seconds at least to download if you have the fastest connections. The tile server is able to update the map, for example, when zooming in, zooming out, using what looks like grid squares, and I hope that you could see that on the screen there. Because the internet is so much faster, you may not notice that only certain parts of the maps update, but that's what's happening, right? Those are the tiles, these squares are the tiles. GeoServer is responsible for calculating and thus efficiently making those tiles update in the background for us. So multiple tiles are received from GeoServer in order to display a map at any point in time on the zoom. So when you zoom, these tiles also get refreshed. Most of the tiles probably get refreshed in the process. This essentially means that the map should load faster. So for example, if you're only zooming into the North America area, it might reuse tiles that are already there, and that's how it speeds up the process. It gives the so-called illusion. It is not really an illusion. It's actually happening that it is faster, and it speeds up the process of loading those tiles. Our example code handles whether the layers are vector or rasterized, and then Mapbox, as I said, it renders that to the user. I want to show you what the data looks like in the background of all the beautiful maps and points. It's a little bit intimidating at first, but it's actually simple. The vector format GeoJSON, which is on the screen there, is a good example of how data can be stored in vector format. This example shows a single point referred to as a feature, which contains multiple properties, and you may see the text word properties in there, and that's why I'm using that. If you look carefully, you might be able to find the ID, the icon type that is inside of this data. So it's very easy for us to add additional properties or data to specific data points when we are using the GeoJSON format. It could be species, it could be genus, and that's how we originally did it. So what we did was we had species under properties. We would actually have a section instead of ID. We have species, we have genus, all of that information inside of there. The issue is every time we add additional information, it's not just for one property. It could have 10,000 properties. So you could actually increase the data by just adding in the species by, let's say, 10% or 25%. And if it's like just 7,000 trees, you're okay. But if it becomes any bigger, obviously it's going to take longer for it to download. So what we do is we remove additional properties. We took it out of here to speed up the time. And we use IDs, so the ID here, TGDR001, for example, and we cross-reference that to the database tables we have in the background. So a lot of the data that we have is stored in Postgres. It's a database server, and we retrieve information such as the species, the genus, etc., from there instead to speed up the map design. All right. And this is just a sort of a cycle that is happening here. So we developed an API, application programming interface, that converts the table into GeoJSON format for the initial 3 points, which I kind of showed here, right? And you see, this is when the map initially loads. That really, really core data comes in. Then the data we might get, the additional data that comes in from TPPS, which we touched upon as well. Emily did a great job touching on that, and that gets imported into the database table in the background. And so what you're seeing here is the database table in the background where all of the data is being imported, right? And then after that, the CartograPlant displays it onto the map. And when you click on a tree, then it queries back. It goes back into the database and brings back the genus, the species, and the subkingdom. Of course, it always needs the latitude and longitude, which is already located in there as well, too. And that's kind of how we get all of this to work within seconds, basically. Now that we touched on the vector layers, I want to touch very quickly on the rasterized layers. The data properties are stored within the actual layer files itself. So it's totally different. It's not like what you saw before, where you had this very long textual representation of the information and so forth. GeoServer has its own pre-coded API functions that makes it easy for us to extract data and receive GeoJSON as well. So it actually extracts it from the file. This is what GeoJSON is. This is what GeoServer is doing in the background. It's pulling that data from the file, and then it's actually generating on the fly a format or a GeoJSON format that we could actually use in real time to display that data to the user. And what you see is a screenshot in this example of where I would have clicked on a point and I would have had the mean annual temperature layer enabled. And what it does, it queried GeoServer, it brought back the information. So it automatically queries GeoServer to retrieve the manual annual temperature for this particular point, which is latitude 20.828 and minus 100.106. The result is we get the mean annual temperature, which is 21.162 degrees Celsius. So our servers are working really hard in the background to get this out to you guys very quickly. I'm nearly finished. I'm beginning to close up here, but I want to touch on the components very quickly because CartograPlant looks like a map, but it's more complicated than that. As you can see, it actually takes 4 main components of CartograPlant to do all that it does. The CP UI, the map that the user sees, the CP admin, the background control, that does the background control, the CP API, which the map pulls metadata from, and also the map API where layer data is outputted to the map UI. All of these components work with the layers in different ways. The admin organizes the layers on the UI. The UI displays the layers, obviously, to us, the users. The API pulls embedded data from what is in those layers, and the GeoServer API as well outputs the layers and the zoom levels that we see on the UI. We spoke about the map UI and the GeoServer a bit, so I just want to touch quickly on the admin UI that controls some critical aspects of the map user interface. I hope you can see from the screenshot that the admin UI stores the GIS server configuration, the API server configuration, and it's primarily used to organize the layers themselves into groups. And as when you get a chance to look at CartograPlant, you'll see that we have hopefully some well grouped sections that you could click on those layers. In addition, you can pre-configure each layer with details and options of all sorts of different things. So for example, when you have range maps, range maps are different from point maps. And so with range maps, you may want to add like colors. So we have different colors that you could choose to change the range maps. All of these things are configurable on the CartograPlant admin UI side of things. You can actually hide data as well. So for example, we might get a layer that has some it's not random data, but data that we don't really necessarily need to display. It might be polygonal data, mathematical data that is not really useful at that point in time. We can actually, from the UI, we can actually hide those unnecessary information that the user may not be interested in as well. All of that is configurable on the CartograPlant admin UI. I left out the CP API because this is a command line tool that we use for additional APIs as well. But and we use this for like the analysis, for connecting to Galaxy to run analysis, etc. But I have to mention that the API is used to run jobs in the background, and because those jobs are running for a long period of time, basically the user interface will poll to find out when those jobs are completed, because we don't want the user interface to time out in any way. All in all, this hierarchy is hopefully easier to understand. At the bottom, we have the raw data or the processed data, usually stored as files or in some cases database tables. GeoServer reads this data and is able to output this data as a layer, which can then be seen on top of the CP UI, which is a map interface. In between GeoServer and the map, the CP admin controls the categories that are seen on the map, for example, the environmental layers. And hopefully this makes even more sense. The UI is where the user gets a list of the environmental layers. And then when the layer is clicked, it calls GeoServer. GeoServer looks up the file, generates the tiles, and then the tiles go straight back to the map, which is the user interface, of course, that we are accustomed to. When a user clicks on a point on the map, it queries back GeoServer, looks up that data, brings it back to the map interface. And there you have it, a really crash course in terms of GIS and how CartograPlant works. And of course, a quick behind the scenes look at environmental data and how CartograPlant components work. Thank you so much for being an awesome audience. And if you have any questions, I can try to answer them as well too. Thanks so much.